Hello friends, welcome to this session. Today we are discussing on the topic Maxwell-Boltzmann statistics. In Maxwell-Boltzmann statistics, let us examine how a fixed total amount of energy is distributed among the various members of system that comprising n particles. It may be atoms or molecules, etc. Let us assume that the particles are identical but sufficiently widely separated to be distinguished. Example, molecule of a gas. Let these particles be distributed among the S cells of the system and designed by A1, A2, A3 up to AS. Let these cells accommodate the N1, N2, N3 and Ns particles respectively. Let N1 particles in the cell A1 have the energy U1. N2 particles in the cell A2 have the energy U2 and so on. Now we are interested to find out that how the total energy is distributed among the various particles of the system. That is, how many particles on the average have energy U1, how many have energy U2 and so on. So we required the priority probability, that is GI, that a particle will occupy the ith cell and is given by GI is equal to VI by V. Here Vi is the volume of ith cell and V summation Vi is the total volume of the entire system. Equation 1 reveals that GI is proportional to the volume of that cell. This is because the cell with larger volume has a greater probability for occupation of a particle than a cell with a smaller volume. We have seen that a probability that N1 Ni particles will occupy the ith cell will be GI Ni, and hence the mathematical probability for the distribution of n particles among the S cell is given by equation W, that is the probability is equal to n factorial divided by n1 factorial, n2 factorial up to ns factorial into g1 raised to ni, n1, g2 raised to n2 and up to gs raised to ns. So equation number 2. When the cells are all of the same size, then the priority probabilities G1, G2 up to Gs are each equal to 1 by S. Then the equation 2 reduces to W is equal to n factorial divided by n factorial, n2 factorial up to ns factorial into S raised to minus n. Equation number 3. So equation 3 can be written as equation 2 can be written in the form of W is equal to n factorial, the product of ns factorial, then product of g s raised to ns. Here product of ns factorial is equal to n1 factorial, n2 factorial, n3 factorial up to ns factorial. And taking the logarithmic of the term, this is a last equation, the product of gs to ns is equal to g1 n1 g2 n2 up to gs ns. Take the logarithmic on both sides of equation 4, that is the probability of n factorial divided by product of ns factorial into pi gs raised to ns. So we get the log w log n factorial log into pi gs ns, this is the product of probability, prior probability, minus log product of ns factorial. Here the term log n factorial is here. So we use the Stirling's approximation. Already we discussed about this log n. So according to Stirling's formula or approximation, log n factorial is equal to n log n minus n. So we can substitute this value log n factorial by the Stirling's formula. So we can write the log pi of gs ns, the product of gs with the product of prior probability gs ns is equal to log g1 n1 log g2 raised to n2 plus up to log gs raised to ns. So here we are substituting the values. So we get n1 log g1 plus n2 log g2 plus up to ns log gs. So we take the average, that is the summation of ns log gs. So this ns is the number of particles for corresponding cells, and this is the prior probability of the that particles in the system. Then we take the log of pi ns factorial is equal to log n factorial, n2 factorial, n3 factorial up to ns factorial. So we get, by solving it, the log n factorial plus log n2 factorial plus up to log ns factorial. By substituting all these values, we get n1 log n1 minus n1 plus n2 log n2 minus n2 plus up to ns log ns minus ns. Then we get the equation n1 log n1 plus n2 log n2 plus up to ns log ns whole bracket minus n1 plus n2 plus n up to ns. Then we get the summation of ns log ns minus summation ns. So this term gives the ns summation ns log ns, and this term gives minus summation ns. So we get summation ns log ns minus ns. So equation number 10. Using equation 7, 8, 10, so we get the equation 7 that yields the probability of logarithmic probability is equal to n log n plus summation ns log ns gs, this is the prior probability, minus summation ns log ns. We have the conditions for maximum probability as, so therefore we differentiate with the three terms. First, that is the del log w is equal to 0. Second, del summation ns is equal to 0. And third, summation ns us is equal to 0. By using these 12 equations, take the differentiation of equation 11, one obtains. So del log w is equal to 0 plus summation log gs del ns minus summation del ns plus log ns del ns. Or we can write this equation like this one, log del log w is equal to, so summation log prior probability with s gs del ns minus summation 1 plus log ns del ns, or del log w is equal to summation log gs del ns minus summation 1 plus log ns del ns, equation number 13. Using equation 12, 1 and 13, this 12, 1 and equation 13, that gives summation log gs minus summation log ns del ns minus summation del ns is equal to 0. So we get the summation log average logarithmic of gs by ns into del ns is equal to 0. Here the combining of summation del ns is equal to 0. So we rewrite the equation 12 second and 3, and we gives the summation del ns is equal to 0 and summation us del ns is equal to 0, and combining with equation 14 by the method of Lagrange method of undetermined multipliers. That means we multiply summation del ns is equal to 0 by minus alpha and summation us del ns is equal to 0 by minus beta, and then adding with equation 14 we get summation log of gs by ns minus alpha, substituting the value of this minus del ns, then minus b with us bracket close del ns is equal to 0. Here the alpha and beta are the undetermined multipliers and are known as Lagrange multipliers. So equation 15 to hold good for all values of s, the quantity in bracket must vanish. So we get log of gs by ns minus alpha minus beta us is equal to 0. Or we can write gs is equal to ns exponential alpha plus beta us, or ns is equal to gs divided by f exponential minus beta us, that is equation number 16. Or we can write ni is equal to gi divided by e raised to alpha plus beta us. Here f is the exponential of alpha. So equation 16, that is ni is equal to gi divided by e raised to alpha plus beta us, or ns is equal to gs by f exponential minus beta us, this is the writing method, is called Maxwell Boltzmann distribution law, and beta and f are called the distribution modulus and degeneracy parameter respectively. We have seen that beta is equal to 1 by kt, that is the Maxwell Boltzmann constant. Equation 16 gives the number of particles for ns, processing energy us. As is evident that gs depends on the size of the cells, it follows from equation 16 that among the cells of equal size, those having lower energy will be more filled or occupied than the cells having higher energies. This shows that the number of particles decreases exponentially with energy. That is, n2 is an exponentially decreasing function of us. So this shows that the exponential decreases function of us. Equation 16 can be also expressed as in terms of n is equal to summation ni, that equals to summation gi into e to the power of minus alpha e to the power of minus beta ui, that equals to z raised to e minus alpha, where z is equal to summation of gi into e to the power of minus bui, and this is called as a partition function. So we can write ni is equal to e to the power minus alpha z minus alpha z, or we can write e raised to minus alpha is equal to capital N by z, or final equation, that is ni is equal to n divided by z e to the power of minus b beta ui, that equals to n by z, just we are substituting the value, e to the power of minus ui by kt, as it is value of the beta is 1 by kt. So this equation representing the Maxwell's Boltzmann statistics. I hope you understand better. This is the mathematical expressions unit. So try to solve it and clarify all the details, how the Stirling's formula is used, how the Lagrange method is used, how the alpha and beta is undetermined multiplier is multiplied. So we can conclude this session. Thank you very much.